Hello there, everybody, and welcome. This is Professor Thayer here with you today in Shreveport Airport on my way to American Chemical Society and coming from Louisiana Tech, where I just gave the keynote speaker for the Students Physics Society, which is why I'm not going to be here next Wednesday because I'll be in San Diego at American Chemical Society. So I am going to go ahead and record your lecture for you today. So let me go ahead and share my screen with you. More. Share. Share screen. Screen. All right. And so now you should be able to see that. Put this down. And here we go. Lectures. All right. So welcome to MATLAB. This is going to be a 1/4 course here at Wesleyan. It meets on Wednesday evenings, and we are going to learn how to work with MATLAB. This is an introductory course. This is at the 100 level, so the assumption is that you do not know how to program, although some people may have some programming experience. A lot of people who take the class do have programming experience, but we will be starting from the beginning and teaching you the basic skills on how to use MATLAB and how to leverage that for doing some data analysis. So we'll go through our course overview. We'll have a first view of MATLAB. We'll take a look at variables and variable assignment, formatting, operators and functions, and constants and random numbers. So there's no time like the present to get started because it's a 1/4 credit class. We do only meet a total of 7 times plus the exam. So let's just see the mechanics of our class. So the objectives of the class are to learn the basic programming skills. So you want to learn how to read, write, and reason about simple programs. We're also going to learn some specifics of MATLAB. So we'll be learning the syntax of writing a program and understanding programs written by others. And we'll also use programming to solve interesting problems. So learning how to break problems down into individual pieces you can solve with the tools available, and see how we can synthesize solutions by combining those solutions together. This is your course calendar. This is available to you on our Moodle page, as are all of the things that we're going to be sharing with you. So this just gives a quick overview. These are the week numbers in the academic year. So coming back from break, we are in the second half of the semester. So we begin in week 8 through week 15, which is the final exams week. So these are the readings. Now, these are taken from a book called MATLAB, A Practical Introduction to Programming, and this is written by Stormy Attaway. So the deal with this is that, as you can see, we will only get through 5 chapters because it is a relatively short course. So I would encourage you to consider buying the book, but we do have scans, some selected scans available for you on the Moodle page, which you may also want to look at for your personal use. So today we're going to be covering chapter 1, Intro to Programming with MATLAB. And then after we have our lectures, we will also have time to practice the things that we're trying out. So we'll talk for it in when we first meet. Then we will take a brief break. Usually we have time for about a 15-minute break between the lecture and the lab. And then we'll move into lab mode, which means you will practice with some examples on the things we have talked about in that lecture. So ideally, you should be reading over these chapters before you come. Obviously, you haven't done that before today because it's the first meeting, but you do want to just look over that material, and so you'll get the most out of the classes. So we'll basically following chapters 1 through 5. So we cover intro today, vectors and matrices next week, programming, which is more or less how to write some functions. That's what would be the equivalent in Python. Then we'll also take a look at the statements, and then we will have the flow control with looping. So this covers the major concepts that are the basics of programming. And then, of course, there are many toolboxes, which are the add-ons in MATLAB, which is kind of like using the Python libraries, if you're familiar with that. So we don't cover all the toolboxes because we couldn't possibly cover all of them, but you would have the opportunity to explore them through some of our additional exercises or involving them in your project. Or if you are new to programming and that's not of interest to you, you also don't have to do that. So we do have to have an exam, so that will happen on 13. So we'll have an exam in the first part where we would normally do our lectures, and that will be followed by the project workshop. So in lieu of a final exam, what we will do is we'll do some projects. So your final projects will consist of writing a MATLAB script that will do a particular thing. So you may have some data analysis that you're interested in, or you may want to write a program that does a particular activity. Typical things that students do are usually to write some kind of analysis script on a data set of interest to them, but we have had projects of other kinds that are more oriented to some specifics, like, I don't know, analysis of images, for example, bioinformatics projects, these kinds of things. So I'm pretty open to what you want to do for your project. The main criterion for me is that we need to be sure that you are exemplifying what you have learned in the class. We'll have much more to say about that as we get closer to the projects, but just so you're aware, there will be a final project. The project workshop, which happens the same day as the exam, will be our opportunity to go through that. Notice that we will have the proposal the week before. So in our lab time, we will also go around and talk about your ideas for your project. And then the project workshop is where you can get some help after you've had the opportunity to get started on that. And our final meeting, we will have the project update presentation. So this would be a preliminary results. So each student will have the opportunity to share with the class what they have been working on and sharing their preliminary results. So we don't expect that you are finished at that time, but we will be having that opportunity to share with the class. And then it will have the help session after that for whatever remaining time we have. And then during the final exams week, you would have your project due when your exam would have been, which is 10 p.m. Well, so 7 to 10 on that Wednesday, which would have been like class time that week, because that's how night classes work. Your exam is when your class would have met. So that's when your project will be due. So many of you may want to do a live demo at that point, which means talking through your project with me. We'll have many more details of that coming up as that becomes closer to us. Okay. So also we have the homework for the class. So what you're going to be doing is you're going to be working some problems at the end of the chapters in the readings. So this is, okay, so I will also mention about the book that one of the problems, if you don't get the standard edition, if you get the international edition, we notice that the problems may be different. That's the other reason why we have the scans available for you. So what you can, because people come in from all different levels of background and many different reasons why they want to take this class, you can select 10 problems out of the ones provided to you at the end of the chapter. So oftentimes there's about 30 to 40 problems presented there. So what you should do is select 10 and you should work on those problems, and that will be your homework assignment. So I'm not going to say like you have to do this problem and that problem. It's going to be that you're going to work on those, and then you would turn those in prior to the start of the following class each week. So that will be how you can practice what we are doing in class. All right, so how is the class graded? So the grade is going to be comprised of several components. 40% will be from your exam, 10% will be your laboratory practice. So those are the exercises we'll be working after. 20% will be your homework problems, and 30% will be your final project. Now, the labs are going to be participation based, and there are problems in the readings, so throughout that chapter, that take you through how to solve some particular problems. So those are the ones that you'll be working in class. And then, as we mentioned, the homeworks would be taken from those problems at the end of the chapter. So that's what you would be doing. And then we already mentioned that you will be having a final project. We have a number of resources and support for you. So first and foremost is me. You can feel free to reach me during my office hours, which Tuesdays 1 to 3 p.m., which I realize is perhaps not the most convenient time. I have an extremely busy schedule this week, and I'm teaching quite a lot of classes, so that's why I don't have a lot of other options during the quote normal business hours. So you can reach out for an appointment and we will figure something out if you're not able to make the office hours. We also have the Quantitative Analysis Center, and so this is in the same building where our lecture is at, and the QC the QAC encompasses a lot of things, but they do have tutoring. So there will be a TA for this class, and that's going to be Tara Pandy. She took this course previously, and she is going to be helping out with that and also helping with the grading of your homework. We also have the ITS help desk. Now, this is very helpful if you're having any issues with downloading and installing MATLAB. I'll show you the link for how to do that. But if you're having issues with that, the ITS help desk may be the place for you to go. The other ITS help desk will, I'm sure you already know about the help desk, right? For issues with internet connectivity or your phone won't go online, those kinds of things. And so you can reach out to them for those sorts of things, but they really shouldn't be answering questions about like your homework, right? That should go to the TA or to me. Right, so who is this course for? So the prerequisite skills are, we expect you have some basic computer skills, like you know how to open a program that you can edit some files and save files. We don't specifically expect that you have programming experience. Some people come in with little or no programming experience, and that's perfectly fine. And there is no prerequisite coursework. If you do know how to program already, this class may also be appropriate for you if you are interested in building out skills working with MATLAB, but do understand that it's a 100 level class. So this is appropriate for people who want to start working with MATLAB. Maybe you're in a research lab or just interested in the graphing capabilities of MATLAB, which are outstanding. Those would be some of the things that often motivate students to take the class. Maybe you're looking to apply programming in the sciences, humanities, arts, any subject. You could learn MATLAB basics for research to be ready to learn discipline-specific applications. So there are a few labs on campus that are working with MATLAB actively, and this could be a good way to get up and started. And maybe you just wanted to gain some hands-on experience with a project-based learning experience, which we provide in this class because you will have the final project to work on. So who is your professor? Well, that's me. I am an associate professor in the College of Integrative Sciences, and you can find me in room 37. I also have a lab in Hall Atwater 66. So those are the typical places you can find me. I also teach in the National Education Equity Lab, which is an outreach program for high school scholars. And I'm also, you may find me teaching a variety of classes. So most of you, if you have met me before, probably saw me in computer science. I also teach in the chemistry department. I now picked up physical chemistry for life sciences. I've taught chemistry and computer science and some molecular biology and biochemistry. And my research interests are in computational chemistry for allosteric drug design. So we try to design some anti-cancer agents using information from molecular dynamics simulations and also artificial intelligence to generate those molecules that act long range to rescue mutant proteins. Few fun facts about me. I'll be asking you some fun facts, so only fair that I tell you some. I did graduate from Wesleyan, so I sat in your shoes at one point. I have rescued 2 greyhounds so far. And also I was a semi-professional violinist when I was a postdoc in Chicago. This is the book that we will be using. So this is Stormy Attaway. That's your author right here. And here's your MATLAB, A Practical Introduction to Programming and Problem Solving, 5th edition. I do encourage you to get exactly this edition if you're going to purchase the book, because the other editions are not current with current MATLAB, and the international edition has different problems in it. So you can buy a hard copy at RJ Julia Bookstore, and there's also the hard copy and ebook available at Amazon.com if you wish to buy it. Also, I'd like to make you aware of our Moodle website. So here is what this looks like, and this is where you can find the various parts that will be available. So you just go and find Moodle off of your West portal, just like you would for any other class, and then I just bookmark it for easy finding, so you can do the same thing. This is where you'll be turning in your work from the lab and also your homeworks. And this is where you'll find any announcements and other things pertaining to the class. So also the syllabus, course calendar, right, and the handouts, and if there were any notices, although I usually just email them, and also the slides from the lectures will be available here as well. All right, so then that is about the class. Let's go ahead and get into actually working with MATLAB. So MATLAB is put out by a company called MathWorks, and they are located just outside of Boston, Massachusetts for their headquarters. One of my lab members now works at that company. They put out some fantastic videos, so I would encourage you to go to the MATLAB homepage and take a look at some of the resources they have. This is the link to their introduction video, and I would also encourage you to just make use of that and to look at the resources they have, because they explain how to do a number of different interesting calculations there. Their employees actually get paid to make free resources for the world to use, so I encourage you to use them. All right, so how can you actually get MATLAB? So you can download it from Wesleyan. We have a site license for this. So this is the link for the student download. So I would encourage you to do that. Now, when I download and install it, I have to do it via a different route. But this hopefully should be straightforward for you. As a faculty, I can't use this link, so I can't make screenshots for you and so on. But you would just go there and you would download the MATLAB following the links for that. And if you're having any issues with your account, access to those things, ITS desk is there to help you with those aspects of getting this. There also is a free version, like a temporary trial version you can get online. And the other way you can work with MATLAB is that it's installed as part of our standard image on all the machines around Wesleyan. So the way that you want, and by the way, it takes a while to install. As I remember, it was like over an hour or so to install mine when I got that installed. So ITS had to come and install it like off of a CD or something on my computer because I didn't have the student access. But anyways, just be prepared. It's a big program and it will take a while to install. But after you've got it running, you should have a link like this on your desktop. So you would double click on the icon. You could also locate it in the start menu desktop. You could search or use Finder if you're on a Mac. I'm working with 2023A. There may be a newer version installed, but this is the one that I have. And then you will see the MATLAB splash screen, which looks like this. Pop up, and then MATLAB will start. So let's just get familiar with the MATLAB desktop environment. So once you open MATLAB, it looks like this. So my video is covering. So there are a couple of different features on here. So we have this arrow over here to view the workspace. So this will show the value of the variables defined by the user. This here is your command window. This is where you'll be spending most of your time and typing your code here. So you recognize this because it says f of x and it's got these little chevron arrows to get you started. And this is where you can see the current folder window. This will show where the files will be saved on your computer, because as you develop suites of programs, you may have multiple things interacting, and we'll see that as we get into writing the programs in MATLAB that is working with the functions. You can also do things like undock the windows to make a customized view. So you can use the arrows in the upper right corner in the windows, and the workspace and the current folder can be undocked. So you see how this one now is no longer stuck inside. So you can make those smaller windows be larger or smaller, and the little arrow is points right here that you can find over here. So this works like a lot of other programs work, but it allows you some flexibility. So to redock, you use the arrows in the upper right and use select dock, and it will pop it back in for you. So there's a number of ways you can customize the work environment. So you can maximize or minimize the window panes using the arrows in the corners. You can just grab and pull. Minimizing will create a tab for that window. So you can actually minimize it, not system-wide, but inside your MATLAB. See how this has now some things recessed over on the sides. Maximizing will just redock it at its previous size. So you can just basically click on these things in the sides. There's also layout in the environment section. So you can use the layout, select layout to select the default layout of window panes. So in case you did something creative and then decide you didn't like it, you can just go back to the standard by doing this. In the environment section, you can use the layout show to select what windows are actually going to be shown. So you can pick layout show and then the command history, for example, to make your view match that one which is shown in the textbook, because our version usually does not show that by default. There's also the tool strip. So this goes across the top. Notice we have the home, plots, and apps. So and these tabs are different ones that we're going to be seeing throughout the semester. So usually we're in home, and this is the things that are being shown in home. This has the variety of functional sections, and each functional group has buttons for similar tasks. And this, if you're used to using Windows kinds of machines, then you're probably pretty accustomed to this. All right, so with that in mind, I would just encourage you to spend some time today looking through your MATLAB and just getting familiar with that. And now let's get into some content of what you can actually do. So starting at the very beginning, what would we want to do? How about variables? All right, so the first thing we might want to do is figure out how to do some variable assignment. So this is pretty straightforward. Variable assignment will assign a value to a variable. So just like in math, you do, x equals 5. And so this is a very similar thing that we can do in MATLAB. Notice that the % symbol is going to allow you to comment your code. So this is interactive, but you can put some comments here if you wish. So here, for example, we can do my num equals 13. So this is an example of variable assignment, and what it will report back out is my num equals 13, just like so. The value can be expressed as an expression, and an assignment operator would be used, and that assignment operator is the equal sign. It's not quite exactly the same as it would be in math, because it doesn't truly mean equal. It means gets the value of, and so it creates the variable table and adds that into your variable table, and that's how it works. So you do variable name equals expression. You can also put the semicolon after. So if you get really annoyed by this, making all this space and reporting back what you already put there, you can just do the semicolon. Okay, variable tables, as we were mentioning, can explicitly be displayed. So the variable table will report all the defined variables and the corresponding values, and the variable table appears in the workspace. You see it right here. And the variable table will update whenever you reassign a value to a variable or you add a new variable. There is another special variable in MATLAB, and that's called ants for answer. So ants is used to hold the value of an expression if there's no particular variable given to it. So suppose you just type 3 plus 3. So the ants variable will get the value of 6. So it appears in the variable table just like any other, but it would get overwritten even if you didn't call it ants if you use just an expression that's not stored in any particular variable. So initializing a variable will create that variable, and it assigns a value to it. You can increment a variable by adding a value to it. So we're showing some of that here. Y gets the value of y plus 1, right? So here it's initialized, you add 1 to it. You can also do decrementation by subtracting, and it works a lot like other programming languages if you have some of that experience. Okay, there are some restrictions on how you can set up the variables, right? So there's some limits. It must begin with an alphabetic character. The name can contain letters, digits, and the underscore character. So it's allowed underscore, but it's not recommended because if you start using this with other programs that interact with MATLAB, it will have a special meaning in those situations. So we're not actually encountering that in class explicitly, but if you want to have compatibility, it's a good idea to avoid using the underscore and instead just use camel case. That is when you just start putting the capitalization throughout the word. So here's like Corey Catfish, for example. You also should not use MATLAB keywords. It's going to be case sensitive and there are built-ins, and you should pick names that are going to be mnemonic so that it's easy to understand what they mean. There are a number of variable types in MATLAB. So a variable type determines the properties about that variable, the type associated variables with a class. So we'll see this in the context of object-oriented programming. So numbers with decimal part will be floating point. So there's single and double precision, which tells how many different places it will count out to. So there's 32 and 64-bit are the typical ones that are available. So for this class, 32-bit should be fine for most things, but if you do need greater precision, there is also the integers. So these also have precisions that can be associated with them. So 8, 32, or 64-bit. The unsigned integers that, and by this we mean integers not including the negatives, record only the number and no sign, and also come in a variety of the bit size 8, 16, 32, and 64. So the difference between these two is that int would allow negative and positive values, where unsigned ints would only allow positives. So you can do view space arrow, choose columns class if you want this to actually report back to you what the type that it was assigned would actually be. So here we can actually just see in the workspace that it is telling you about the different kinds of variables you could have here and what the values are. And this will also tell you their class. So these are all double precision. There are also text-based variable types. So the character type char can be used to store two types of data, single character or character vectors. That's a sequence of characters and it would be enclosed in the single quotes. Okay, so this is type character and this one is going to be type string. So strings can be useful to store characters as a single entity enclosed in double quotes. So the character is iterable, and strings are not. So if you want to cycle over them, then you need to distinguish between these two. Char type is iterable, whereas strings are not. That's what you mean. So this is a type string with the double quotes. You can't process each individual character, but server sides, you can process each individual one of these, and we recognize this because it has the single quotes. And we can see the difference in the class in the workspace. We also have Booleans for relational expressions. So we have greater than, less than, greater than, equal to, less than, equal to. This is double equals for equality. This is testing whether they're equal, and this is the inequality or not equal to. So you may be familiar with the exclamation equals. In MATLAB, it should be the tilde. There are also logical operators, the two pipes for or, the double ampersand for and tilde for not. This is type logical, and they return a Boolean that is true or false. So here's just a couple of examples for you to see. The class type is going to be logical, and it means that it returns back a Boolean. Now it will report 1 for true and 0 for false. Also note that they appear in single quotes, and also that they are not capitalized. So you can determine the type of a variable with the class. So you can simply do a class and then you supply the thing that you want to know what it is. So in this case, we're going to see that this is a double precision. And you can also put expressions in the class to figure out what they are. Suppose you're not happy with the type that it is. Well, you can do type casting. That is to convert one type to another type. You can use casting functions and they have the same names as the target types. So you can convert a variable to a type by having more space made desirable. For example, if you anticipate needing more than like the int 8 amount of space to int 32 space. You could convert a double to an int and so on. You can use on strings and we'll convert it to the ASCII numerical equivalent. So you do casting function and then the parentheses and value. So in my notation, notice that I'm going to put these angle brackets. You should not actually type the angle brackets. I'm using this to tell you to sub in something there. So here are some examples. We have x gets the value of 3.6, and now I can cast it into a different one, and then we can verify the type has changed. We can also look at variable assignment using the defaults, right? And then we can see what the default type is. So we see it was a double, and maybe I did a reassignment and cast it into int 32 instead of the default. And then I could check the type again, and we see that it's at int 32. All right, there's also useful things we can do with the formatting. We have long versus short, loose versus compact, and the ellipsis notation. So this is mainly just for working interactively with MATLAB. So by default, MATLAB will display numbers that have a decimal points with 4 decimal places, but the format allows a particular output format to be used instead. So the short format will be 4 decimal places, which is by default, and the long is 15 decimal places, which you probably don't need. So you could just do format and then specify what it is you want. And if for some reason you don't have the shorter format, you can just do short format short in your script, and it will do that henceforth. The format command also accepts keywords pertaining to the compactness of the output. So you might have noticed that it's kind of spread out, and the issue is that if you want to look at multiple lines simultaneously, you need to do a lot of scrolling to get through the white space, and you may find that unsatisfactory. So what we can do is we can just use the format compact to switch that over. The loose is the default, and compact I find to be much nicer. That's really a matter of your personal choice, but I recommend the compact. The ellipsis operator allows line continuation. So if you have a long line and you want to go to the next line, you just put ... at the end, and you can continue typing on the next line. All right, so operators and functions. So in other words, we mean built-ins. So let's take a look at what we have here. So operators are really just math symbols that do an activity. So for example, you're probably already familiar with operators from basic addition, like the plus sign adds 2 numbers together. So plus is an operator. There are more complicated operators, and you can take higher level mathematics classes to learn more about operators. But and one great thing is MATLAB makes using complex operators fairly straightforward. So let's just understand some of the basics of these and understand what the operator is. So unary operator operates on a single operand. So you would do something like -1. So the minus is the operator. Remember, our percent is the comments. So this will negate the thing that follows it. So in other words, if you do -1, it operates on just one thing, meaning the 1, and that's why it's called a unary operator. A binary operator will operate on 2 things. So you have an operand, an operator, and another operand. So for example, 4 plus 5 has 2 operands. It's the plus, which is the operator, works on 4 and 5 to combine them together. So the precedence rules will follow the familiar ones that you know from algebra. Please excuse my dear Aunt Sally. It might be something you learned about order of operations, but basically inner to outer parentheses, exponentiation, negation, multiplication, and division, left to right, addition and subtraction, left to right. Also, let's just note about the scientific notation. So MATLAB is capable of using the scientific notation. So we would write it something like this: 2 star 10 caret 4. Right? So this is 2 times 10 to the 4th power. And so we see that we can view it like this, and you can also type it in as 2e to the 4. So you would use e for exponentiation, and by default, it will be base 10. We also have some basic functions. So a function operates on input and most will return the output. So you can call a function and that will execute the code associated with it. So you would do function name, and then we have the parentheses, and you would supply the needed arguments for that. So maybe you want to use the absolute value function. You just do abs. Here's the parentheses and you put the thing in there. So you do -4. So the absolute value of -4 is 4. Also note we have the tab completion. So after starting to type the name of a function, if you press tab, you would get a list of suggested matches and also attempts to correct any typos you may have. There's a lot of built-in functions in MATLAB. I mean, really a lot. So you can use some tools to help you identify them. So you can use the help command to identify functions to do the tasks you want to do. So you could just type help, and then you'll get this message, new to MATLAB, see resources, and right, it gives you a link. And to view the documentation, it will also allow you to do that. And you can do all of that right from inside your MATLAB. So when you identify a topic of interest, you can type help and its keywords. So oftentimes what I would do is I would type help and then read through. And then I say, oh, yes, I'm interested in a cosine H, right? For example, here I'm interested in tangent function, right? So then you can do help tan and then it will delve into these things in more detail. It also tells you other things that are going to be related for it, and it links out to additional information. So it's very easy to discover new tools in MATLAB by just making use of this. There's also a number of numerical functions. So these are about rounding and remainder. These ones are your trig ones. These ones are your exponentials. These are the ones that are your complex. So it's terrific, and this is why MATLAB is used by engineers primarily, because you have so many functions already available. So to use the documentation, you would type help and then the thing you want. So like help sign, and then this help will contain the related functions. And you could also do doc sign, which will just put it in a nicer formatted version. To search for a function by specifying the keywords, you can do doc, and then you can do search tab, look for, and you can also give keywords that you want to search for. And all of these can help you navigate. There's also constants and random numbers built in, which can be really quite helpful. So constants are built-in variables that have unchanging values, not too surprising. So there is pi. So we see that we have pi built in. We have I, which is the square root of -1. So we see this being represented in the I and J format. So these are kind of interesting because I and J both are the square root of -1. We also have INF for infinity, and NaN, which is not a number. So for example, division by 0 gets the value of NaN in MATLAB. We also have the random numbers. So MATLAB can produce pseudo-random numbers. You can never get truly random numbers. They're going to be as good as you can get them. The numbers are random in that they are uniformly distributed on an interval. There'll be a seed, and this provides a starting point for the random number generator. And for equal seeds, the sequence of numbers produced will be the same. This is very useful to know if you are using random numbers, because if you need to check your code and it changes every time, it makes it really difficult to see what is wrong with your code because it's different every time. But you can simply just force it to be the same by setting the same seed. So random will produces a uniform distribution of numbers on the open interval from 0 to 1. So you can change the seed with range. So you could do range of shuffle. This will be based on the current date and time, which is a typical way of getting a seed. So let's see how we could do this. Suppose you don't want that interval. Well, what you can do is basically apply scalars. So here we're going to have low and high. So we would define the lower limit of the desired range, and high will be the upper limit. So we said you cannot produce random numbers on that range, but you can by using this formula. So you would do rand times, and then you'll have high minus low plus low. So basically you are doing a linear transformation and scaling to make your numbers be on your desired range. And so then we can compute some random numbers, and we can see that if we run it every time that we are going to get different numbers that do fall in the desired range. You can also generate random integers. So a function rand I for integers will allow you to generate random integers on a closed interval from imin to imax, inclusive of the endpoints. And so this one works like this: rand I with the parentheses and the square parentheses, giving the values of 3 to 6. And then we can run this multiple times and see that it is selecting numbers within that range. type ranges, because the amount of disk space allocated to specific types is specified, some limits on numbers that can be stored in the type exists. This is actually a very interesting conceptual idea. So unsigned integers of 8 bits have 2 times 10 to the 8 bits is available to store the integers ranging from 0 to 255, because 256 will require more space than is allowed by the type, right? So how do we figure this out? Because we know how many bits we have, so we know how much storage space that will require. So you can store in int 8 -128 to +127, because this will also make use of the 0th one. MATLAB will tell you the max and min available using the respective min and max functions, or you could also just understand how to calculate this by the combinatorics and the number of bits. So here we can just test this out, and we're just showing you the examples here of how to do this. So we can see that this is how you would see how much space and which numbers you would be able to store. Alrighty, well then, I hope this was a great startup to MATLAB for you. Again, I apologize that I have not been able to be with you in person on this day, but hopefully you will find this as a useful introduction. And I encourage you now to move on to working your lab. So again, labs are participation based. So what you're going to need to do is decide how you're going to work on MATLAB. So either you're going to go to the download and install link and do that, or you can work on one of the machines in Wesleyan that already has it installed. So you can use the one in our classroom, or you can also use any other standard machine at Wesleyan, which should also have MATLAB on it for you. All right, so your lab work then is to go to the chapter 1, and the chapter 1 will have some practice questions in it embedded in the chapter. Those are the ones that have the little explanations. So those are the ones you are going to practice with. All right, and that will be what we do over the course of the semester. All right, and I think you have lost my Zoom window. Alrighty, well, thanks so much, everybody. I hope you have a terrific day, and I look forward to seeing you all in person next week. Bye-bye.